Sometimes you can have an infinite number of solutions to an equation. Sometimes you can have no solution at all to an equation. And then more typically what we've seen is that solutions have exactly one solution. And by solution, I mean what the variable equals that will make the equation a true statement. So we're going to start today looking at the equation a minus 6 divided by 12 equals a minus 2 divided by 4. So I'm going to change my subtraction to addition to start off, and then I'm going to cross multiply, as that's a nice, easy way to deal with solving a proportion or two equal equations. So when I cross multiply, I'm going to multiply 4 times the numerator of my other fraction, which is a plus negative 6. And I'm going to put that in parentheses because I'm multiplying 4 times the entire numerator, which is going to require me to distribute. And I'm going to multiply 12 by the entire numerator of the other fraction, 12 times a plus negative 2. When I do that, I end up having to work with the distributive property. So I get 4a plus negative 24 equals 12a plus negative 24. I'm going to continue to solve from here by adding the opposite of a negative 24 on the left in order to get rid of all of my constants on the left. And I'm going to have to add positive 24 to the right because whatever I do to one side of an equation, I have to do to the other. So I end up with 4a equaling 12a. And I can leave this as 12a or I can put plus 0. I'm going to put a plus 0 just to help me visualize my constant. So my constant is 0. Now I'm going to add the opposite of positive 12a to both sides because I want to bring all of my variables to the left. And right now we're still dealing with addition. So 12a is being added to 0, so we have to still continue to work with our opposite property. So I'm going to end up with negative 8a equals 0. Now I'm going to multiply by the reciprocal of negative 8 on both sides to get a by itself. Remember that reciprocal step is always your last one. And I end up with a equals 0. So the solution to this equation is 0. And let's do a check step real quick. So with my check step, I'm going to put 0 in the place of a, so I get 0 minus 6 over 12 equals 0 minus 2 over 4. So that's going to give me negative 6/12 equals negative 2/4, which is negative 1/2 equaling negative 1/2. So sure enough, 0 is the solution to this equation. That's the number that makes this a true statement. It makes it true that a plus negative 6 over 12 is equal to a plus negative 2 over 4. So a equals 0. So that's just one solution. In other words, there's one answer to this problem. And the way that I graph it is I put what's called a closed circle where my solution is. So 0 is my solution, so I'm going to put a closed circle. So to help you understand, a closed circle is a circle that you completely shade in, and it means equals. Okay, so having a closed circle at 0 means that our solution is equal to 0. All right, and this is called a closed circle. We'll talk about open circles later. But just remember, a closed circle means equals, and that's how we graph. So all of the different equations we've been graphing, or so that we have been solving, we could have put on a graph with a closed circle. So now let's move on to another equation. So let's go ahead and solve this one. Why don't you give it a try and just see what happens. Once you end up solving this all the way, you should end up with two numbers that are not equal to each other. And you could have solved this several different ways. So I end up with 0 equals negative 6. So here's another way that I've solved the equation. Either way, you end up with two numbers saying that they're equal to each other that are not really equal to each other. So whether you add negative 13 to both sides to start with, or whether you add t to both sides to start with, you end up with two numbers equal to each other that are not equal to each other. And what that means is that no matter what you put in the place of t, or your variable, you're going to end up with an untrue statement. And whenever that happens, it means that there's no number that could make this a true statement. And I can actually tell when I rewrite my equation with addition in my first step that this is going to happen. So if you take that very first step there and rewrite it as negative t plus 13 equals negative t plus 7, notice that your variables are the same. I have a negative t here and a negative t here. And we can tell right away that there's no way this can be true, because negative t plus 13 could never equal negative t plus any other number other than 13. So no matter what number we put in the place of t, we're going to get an untrue statement. So for example, let's just explore this. Let's let t equal 1. Nice, easy example. If we let t equal 1 and we put that in the place of t, we'd get 13 minus 1. We put 1 in the place of t, equals negative 1 plus 7. So put 1 in the place of t there. 13 minus 1 is 12. Negative 1 plus 7 is 6. So that's not a true statement. So t cannot be 1. I'm going to let t equal 0. If I put that in the place of t in my equation, I end up with 13 minus 0 equaling 0 plus 7, or 13 equaling 7. That's not true. Okay, so we can't, there are no numbers we can put in the place of t that will make this a true statement. And when that happens, your solution is called the empty set. So this is actually read as the empty set. And it looks like a 0 with a line slash through it. Okay, and the way that you graph it is you don't do anything. You just have a number line that's empty. You don't do anything to the number line at all, because there's no numbers on this number line that will make this a true statement. So if you can tell right away, like I could tell here, that you have the same variable on both sides being added to a different number, you know that nothing's going to work. Just be careful, make sure they have the same sign. The variables have to be the same and have the same sign for that to work, for it to be no solution. All right, let's go to the next example. Go ahead and solve this. So I did not solve this quite all the way, but you can see where I use my distributive property to multiply 7 times d, giving me 7d, and 7 times 1 is just 7. Then in my next step, I add in my like terms. So I have a 2 and a 7 that I added. I just rearranged the order first, and that gives me 9. So I end up with 7d plus 9 on the left and 7d plus 9 on the right. So those two expressions are exactly the same. Therefore, no matter what we put in the place of our variable, we will always get a true statement. So let's finish solving this and see what happens. I can actually stop here, and I know my answer is all real numbers, or any number can work. However, let's keep solving just to make sure. So I'm going to add negative 9 to both sides, and I'll get 7d equals 7d, because those 9s are going to cancel. Again, no matter what I put in the place of d, 7 times d is going to equal 7 times d. It doesn't matter if d is 100, d is negative 10, d is 0. It'll be a true statement. But let's just keep going and solving and see what happens. And then we get d equals d once we multiply by the reciprocal on both sides. So no matter what I put in the place of d, I get a true statement, right? So if I let, for example, for check steps, if I let d equal 0, 0 would equal 0, right? If I let d equal 10, I would get 10 equals 10. Let's just put it back up in the actual equation. So 2 plus 7 times 0 plus 1 equals 9 plus 7 times 0. So I'm putting 0 in the place of d. I get 2 plus 7 times 1 equals 9 plus 0. So 2 plus 7 equals 9, 9 equals 9, true statement. So 0 definitely works. Let's try 10. I'll use a different color. So 2 plus 7 times 10 plus 1 equals 9 plus 7 times 10. So 2 plus 7 times 11 equals 9 plus 70. So 2 plus 77 equals 79. 79 equals 79. That gives us a true statement. So then 10 also works for D. So basically anything you put in the place of D is going to give you a true statement. So therefore, the answer here is called all real numbers. So what you put for your answer instead of D equaling something is underneath this you put this symbol. It's kind of like the paragraph symbol. You put 2 lines and then a capital R. So it's a capital R with an extra line. And that's called all real numbers. That's how you read it. And if you'll remember, real numbers are rational and irrational numbers put together. We learned this earlier in the year. So real numbers are rational plus irrational. So basically everything on the number line. So no matter what number we put in the place of D here, whether it's pi, 3.14, et cetera, et cetera, et cetera, or whether it's the square root of 2, or whether it's negative 42.1, it will work. All of the numbers will work. And the way that we graph this, when we come down to the graph, is on the number line itself, not above it, but on the number line itself, we put a line with arrows on both ends. And that lets us know that every number on the number line will make this a true statement. So we have 3 options when we solve our equations. We could end up with one solution that we graph by putting a closed circle, in other words, a shaded in circle on the answer on the number line, or nothing works and then we just don't do anything to the number line, or everything works and then we put a line with arrows on both ends on the number line. So we're going to go down and look at graphing and look at a couple of examples, and then we're going to try these examples down here. So with graphing, if I have, for example, an answer that says x equals negative 2, the way I'd like you to graph it is just have a 0 in the middle on the number line, put negative 2 on one side and a positive 2 on the other, and a closed circle on the solution. And the reason I want you to graph this way is just if we get big answers or small answers or decimals or fractions, it just is easier than putting the tick marks. So technically we should have a negative 1 here and a 1 there, but I'm not going to require you to do that because we're going to get all kinds of crazy answers. So for example, we might get an answer that's x equals negative 22 over 7. So I don't want you to have to draw the tick marks. So you're just going to put negative 22 over 7 on this side, 22 over 7 on that side, and then a closed circle on the negative one, since that's your answer. So there's some more examples of graphing. All right, so here's some examples. I'm going to work each one out and show you the solution after each one, but I want you to give each one a try. For number 1, you should have ended up with negative 2x plus 8 equals negative 2x plus 8, and automatically that's all real numbers. You don't have to solve it any further down. And then when you graph it, it should be a line with arrows on both ends, and make sure the line is on the number line for graphing. For number 2, you end up with 2 things not being equal to each other, and quite frankly, you could have stopped at this point, and you have 3x plus 20 equals 3x plus negative 12, you can tell right away that there's going to be no solution at that point. Or if you're not sure, you can keep solving, and then you have a number line with nothing on it. For this last example, you end up with x equaling 38, so you should have a closed circle on 38 when you graph it.